Welcome to Math 451. This is Oregon Institute of Technology's Numerical Methods class. My name is Tom Bingham. I will be teaching you this quarter a series of methods that will address issues that we've seen in prior math classes along the way when trying to come up with what appears to be impossible problems to solve. You may have recalled when you took calculus doing integration that there were really only a few integrals that you could actually do. When you took linear algebra, even though you may have been able to solve any linear algebra problem, they could get unwieldy if the dimension of the matrix got too large. This quarter we're going to address that head on, and we're going to create algorithms that will produce numerical solutions for what might be impossible to do as a formulaic solution. So why do we start with section 00? Well, many algorithms are best started using the number 0, so why not do that here in our course notes? So let's go ahead and turn to our introduction, and we'll discuss the resources and logistics, as well as the materials that we will be using during this quarter. First of all, my name again is Tom Bingham. I've given you my email address. I will be discussing homework and going into more detail on some of the text material and also the video material by appointment or by email or through scheduled sessions that we'll put together as a class. The textbook we'll be using is called Numerical Mathematics and Computing, available on Amazon or the location of your choice. And also we will be using MATLAB. I've given you the web address there that you can link to download it. It does cost $99, comes with something called Simulink, and optionally you can buy add-on packages that will make MATLAB more effective. I wouldn't recommend doing that for this course. We will be using the base language of MATLAB only. In fact, I will be severely restricting you on what you can or cannot use in MATLAB because we're going to use it as a dumb programming language in order to exercise the algorithms ourselves. And essentially, we're going to be reinventing a lot of wheels that have been programmed, but with the purpose of understanding how these methods work. So what do we cover? Well, we're going to start with numbers. You may think you know all about numbers, but you'll find that numbers have some oddities with them. We are going to look at how they developed and then how they're used in computers today. Primarily, we'll look at two formats. One is an integer format, and one is called a floating point number. More to be discussed on that later. Then we'll start going into how we will manipulate algorithms largely using something called the Taylor series, which we will motivate through something called the mean value theorem. And this Taylor series will allow us to create computational formulas and be able to predict the errors associated with those formulas. Well, what do I mean by errors? Well, all numerical algorithms, as well as any computer's computation, even just adding numbers, produces a little bit of error. And the more calculations that you do, the more error that will result. And we're going to learn how to deal with that. Once we get those basics down, that will take us a couple weeks, then we're going to look at how do we manage matrices and vectors and solve linear systems. Then we'll move on to nonlinear systems. Well, honestly, we will look at one nonlinear equation at a time, except for maybe right at the end of that section where we will at least discuss systems of nonlinear equations. But for the most part, we will build things that your Microsoft Excel and other programs might like to call a solver. And that will be basically solving non-explicit formulas that require solutions. Then we'll move on into interpolation. Interpolation you've probably seen. If you've got two table values and you're trying to get some percentage of the way through it, how do you go ahead and do that? Then the next step will be our calculus tools. We'll learn how to differentiate numerically. We'll learn how to integrate numerically. The integration rules are going to be really important since most integrals you can't do or most derivatives you can. But what you need the derivatives, the numerical derivatives for, is to process differential equations. And we'll end the course there. There is a prerequisite for this class, which is listed. I think you've seen that in the syllabus, so we don't need to go over that in too much detail. So how does the grading work? How do the exams work? How do the projects work, or homework? And it's kind of a good news, bad news thing. There are no exams. There's no midterms. There is no finals. So that might be kind of fun. But the bad news is there is no midterms and there is no final. That sometimes is easier than what you're going to experience. There will be a Gatling gun version of exercise that will come to you every single time we meet. I don't think I miss one session that you don't get some kind of a homework assignment, and you will see the schedule of that here shortly. Because you're graded entirely on homework, which will consist of both hand projects that you write up by hand, scan, and send me the PDF files, and also MATLAB programming, since that's 100% of your grade, I cannot accept any late homework at all. I give you a date and a time that the homework is due, and basically if you don't turn it on time, unless there's an awfully good reason that's coordinated in advance, I have to give you a 0 on that. So make sure you get that homework in on time. There is some extra credit scattered through the course. The course tends to be you either got it or you didn't, and you can lose a lot of points on any given homework, and therefore I've made up for that by giving you the option of doing some extra credit if you want to keep your grade up. How much time do you need to spend? Well, this is a 400 level class. I estimate 10 to 15 hours a week after class. That does not include the time in the class. Or another way to look at it is whatever you spent on differential equations, maybe up it by 50%. I think that's what you're going to need to do. There's going to be a new assignment every class session, which I mentioned. You will be given a week to get each assignment done, possibly the last assignment. You may have a little less than that, but I will try to give you a week for everything. But you will be getting an assignment frequently, and it's just they will be turned in a staggered manner. As far as working as in teams is concerned, I encourage it, but I want you to keep your teams to 2 or 3 people, no more than 3 in any one team. Everyone has to write up their own work. If the homework is to do some math and turn it in, you must do your own. If it's to write a program, you're not allowed to copy and paste anybody else's code. What you are allowed to do, however, is share your results with your team members. If you do so, you must list your team members' names on your homework. Failure to do that will be a loss of points. If you're working individually, that's fine, but you have to specify that too. You say, I worked on this individually. As far as the format is concerned, your MATLAB code that you'll be writing it exists in what's called a .m file. So you make up the name and MATLAB supplies the suffix of .m. I will want you to turn those into me directly. I don't want scans or PDF copies of those. I want the M files. But about a third of your homework is a math problem or some sort of write-up. And those you can write by hand or you can type up in Word. But when you're done, make it a PDF file and send it to me. So what are the rules of the game on this class? Well, the first one is, and this is a big deal, is when you send me MATLAB code, I do not want to change one line of it. So you must send it to me completely debugged and executing. I understand there will be things in your MATLAB code that may not quite give you the right answer, and you will get partial credit for getting partially right code. But code that can't execute at all and it gives me a syntax error is going to get a 0. So you don't want to go that way. I will give you date and times that each homework is due. So this is the form that I keep track of your grades. You can see here every single assignment that you will have throughout the whole quarter. The schedule that you're looking at was for winter of 2015. I will be sending you an updated version of this that shows you what your particular schedule is for this sequence of assignments. So more rules of the game. First of all, MATLAB is best constructed if you write pseudocode first. Well, what is pseudocode? Well, pseudocode is kind of a fake language that you can define yourself. There's certain syntax to it that's normally accepted but not required. And it is a way to organize your thoughts and put down the essence of an algorithm before you really start writing the code yourself. Now, early in the course, I will be giving you some skeleton versions of the program. You'll get some files from me called hints file that might have portions of the code written. As you get about to maybe a third of the way through the class, those start disappearing, and you have to develop your own code yourself. But we'll get off to a running start by me helping out just a little bit. The assignments are cumulative. There are many sections where you'll see like homework 2.2a, 2.2b, 2.2c, and so forth, and those codes are related. So you've got to make sure you get the first one done right and functioning correctly before you go to the next one, because you will be making fairly minor modifications on some of these sequences of assignments. Rarely, and if possible never, will I send you the solution. They are too much work and I don't dare send them out an email, but you'll be able to see them on the screen and go ahead and use them to correct your own work. Okay, so your teams again should be of 2 or 3 people, or you may work independently, whichever you prefer. As I said earlier, do not copy each other's code verbatim. You can use it as a reference for ideas, but you write your own code and you write up your own work. Some more rules of the game. I will never critique your personal homework. I may have sessions online where we discuss common problems that we've been seeing, but I won't debug your code for you after the fact. As far as analytic solutions, I have a high expectation that each step builds logically on the one before. I want to see a very clear, sequential development of the mathematics. And when you scan it, do not photograph it with cameras. They make very bad copies. Don't use cell phone photographs. Also, each problem should be clearly identified. I need the problem number, so do the assignments in sequential order. As far as grades are concerned, I stick with the OIT standard, which you can see on the screen. There is no grading on a curve, it's all fixed. So if you get in that range, that's the grade that you will get. Again, the non-MATLAB homework must be converted to PDF and then emailed to me, as well as the MATLAB code, because I will be running them and you will be graded heavily on key variables that are in the code. As far as acquiring MATLAB, you can get it from MathWorks. There's the link as we go through the course. As far as coding rules, as you are creating your code, never use a MATLAB function unless I explicitly tell you can't. And that includes square roots, it includes sines, cosine, all your trig functions, it includes the exponential function. You cannot use any of them because most of the work is algorithmic, and I may want you to develop the exponential using a Taylor series. It doesn't help if you just call the MATLAB function. Okay, there's other issues on your naming of your homework. It helps if you name it in a way that I'll recognize it. Pick a name that's pretty clear. And finally, the attendance. OIT does require us to have an attendance log. This is going to be the honor system. You will be using these YouTube-based videotapes, and you need to email me each time you have completed one. And then I will mark you down as having attended that particular session. And we will have some meetings together, which we will do by Skype. And you can see my Skype address down there at the bottom of the screen. Okay, so that takes us to the end of the introduction and course logistics. When you finish this, please email me and send me a note that you have, in fact, watched the whole thing. So